Hello everyone. Welcome to SHR Trinity. In our previous video, we explored zero-shot prompting. Today, we advance to the next critical technique, few-shot prompting. In this video, we will cover the foundational interview questions on few-shot prompting, explaining how providing just a single example can drastically improve a model's accuracy and format adherence. Let's get started. Before we begin, if you're looking for practical, industry-oriented training in artificial intelligence and generative AI, SHR Trinity offers a comprehensive 30-hour training program. For complete course details, check the description below. Now let's begin today's interview session. We will now begin with the interview questions for few-shot prompting, Part 1, Basic Fundamentals. Question 1. What is few-shot prompting and how does it leverage in-context learning?
Few-shot prompting is an in-context learning technique where we provide the model with multiple input-output examples, typically 2 to 5, directly within the prompt before presenting the actual task. This allows the model to learn the desired output structure, tone, and reasoning logic without updating any underlying neural network weights. Rather than relying on static system instructions alone, few-shot prompting activates the transformer's multi-head self-attention mechanism over the provided examples. The model identifies the implicit mathematical and semantic pattern connecting the example inputs to their outputs and applies that exact transformation to the unseen target query. For example, prompt, classify sentiment with labels. Example 1, product is great-positive. Example 2, broke in 2 days-negative. Example 3, arrived on time-neutral. Task, customer service was super helpful. A common mistake is providing too many examples that exceed the context window, or using examples that contain conflicting and contradictory output formats. As an interview tip, always highlight that few-shot prompting relies entirely on in-context learning without any permanent weight modifications or fine-tuning costs.
Question 2. How does few-shot prompting differ from zero-shot and one-shot prompting?
Zero-shot prompting provides 0 examples and relies purely on descriptive instructions. One-shot prompting provides exactly 1 example to establish format. Few-shot prompting provides multiple examples to demonstrate variance, edge cases, and complex structural relationships that single examples cannot convey. Zero-shot is ideal for simple, well-known tasks, but fails when output constraints are strict or complex. One-shot fixes basic formatting issues. Few-shot is necessary when the task involves multi-class classification, ambiguous boundary conditions, or domain-specific language nuances. For example, zero-shot, extract keywords. One-shot, gives 1 keyword example. Few-shot, gives 3 distinct examples covering single-word, multi-word, and technical jargon keyword extraction. A common mistake is using expensive few-shot prompts for trivial tasks where zero-shot or one-shot already achieves 100% accuracy. As an interview tip, explain to interviewers that you choose prompt strategy based on a cost versus accuracy hierarchy, test zero-shot first, then one-shot, and escalate to few-shot only when needed.
Question 3. Why is example diversity and balance critical in few-shot prompting?
Example diversity ensures that the model learns the generalized logic of the task rather than overfitting to specific keywords or biased categories. If all few-shot examples represent a single category, the model suffers from majority label bias and will favor that category regardless of the input. Large language models are highly sensitive to the statistical distribution of tokens in the prompt. If 4 out of 5 few-shot examples demonstrate positive sentiment, the model's output probability distribution shifts heavily toward positive, leading to high false positive rates on negative or neutral inputs. For example, in a 3-class intent classifier, billing, tech support, sales, providing exactly 2 high-quality examples for billing, 2 for tech support, and 2 for sales ensures unbiased classification. A common mistake is providing multiple few-shot examples that are nearly identical in phrasing or heavily skewed toward one particular class label. As an interview tip, emphasize that in production pipelines, few-shot example sets must be balanced uniformly across all target classes.
Question 4. What is the optimal number of examples to use in a few-shot prompt?
In most enterprise applications, the optimal number of few-shot examples is between 3 and 5. Research shows that beyond 5 examples, the marginal accuracy improvement diminishes rapidly while input token costs and latency increase linearly. Transformer attention mechanisms experience diminishing returns as prompt context grows. Adding 20 examples consumes valuable context window space and increases time to first token, TTFT, without providing meaningful accuracy gains over 5 well-curated examples. For example, a data extraction pipeline achieving 94% accuracy with 3 examples, 96% with 5 examples, but only 96.2% with 15 examples while costing 3 times more per API call. A common mistake is stuffed prompts with 20+ examples believing more is always better, leading to context window exhaustion and inflated API bills. As an interview tip, state that 3 to 5 examples represents the sweet spot for balancing token economics with model accuracy.
Question 5. How do you format and delimit examples in a few-shot prompt for maximum clarity?
Examples should be formatted with strict, uniform structural templates and separated using clear visual delimiters such as XML tags, markdown headers, or triple hash symbols. This prevents the model's attention heads from bleeding context across examples. Unstructured text prompts cause attention bleed, where the model confuses the output of example 1 with the input of example 2. Using explicit tags like example and input/output establishes distinct semantic boundaries that the attention mechanism respects. For example, using XML structure, example input item A/input output category 1/output/example followed by task input item B/input/task. A common mistake is separating few-shot examples with plain new lines or inconsistent indentation, causing the LLM to misinterpret where an example ends and the task begins. As an interview tip, mentioning XML tags or markdown delimiters demonstrates production-level prompt engineering standards.
Question 6. What happens when few-shot examples contain contradictory logic or formatting errors?
Contradictory or noisy examples degrade model performance significantly, as LLMs prioritize pattern matching over written system instructions. If your examples contradict your prompt rules, the model will follow the flawed examples rather than the instructions. Empirical studies show that LLMs learn syntax and output formatting overwhelmingly from the provided examples. If an instruction says output JSON but an example outputs plain text, the model will output plain text because example conditioning overrides system instructions. For example, prompt instruction, return lowercase only. Example, input, hello-output, world, uppercase. The LLM will output uppercase text for the task. A common mistake is failing to audit few-shot examples for subtle typos, inconsistent casing, or conflicting labels before deployment. As an interview tip, state the golden rule: models mimic examples, not instructions. Your examples must be 100% error-free representations of the desired output.
Question 7. How does few-shot prompting impact token consumption, API costs, and latency?
Few-shot prompting increases input token counts significantly per request, which directly increases API billing costs and increases time to first token, TTFT, latency due to extended prompt processing. Every input token in a prompt must pass through the transformer's self-attention matrix. A 5-shot prompt adding 1,000 input tokens across 100,000 daily API calls generates 100 million extra input tokens per day, drastically increasing cloud infrastructure expenses. For example, comparing a 0-shot call at 100 tokens versus a 5-shot call at 1,100 tokens, at scale, the 5-shot prompt increases monthly API expenditure from $300 to $3,300. A common mistake is deploying long few-shot prompts in real-time user-facing applications without analyzing token cost and response latency trade-offs. As an interview tip, highlight techniques like prompt caching or model distillation as solutions for reducing few-shot latency and cost.
Question 8. Can few-shot prompting be used to enforce strict output schemas like JSON or XML?
Yes, few-shot prompting is one of the most effective techniques for enforcing complex structured output schemas like JSON, XML, or YAML, especially when working with models that lack native structured output guarantees. LLMs easily grasp structural syntax like curly braces, key-value pairs, and array formatting when shown 2 or 3 valid JSON examples. The model's generation probabilities become constrained to valid JSON syntax tokens following the pattern established in the examples. For example, providing 2 examples where input text is mapped to a strict JSON schema, user_ID, 101, status, active, tags, VIP, verified. A common mistake is relying solely on textual instructions like return valid JSON without providing a concrete JSON example in the prompt. As an interview tip, explain that combining few-shot examples with JSON schemas provides the highest reliability for automated data extraction pipelines.
Question 9. What is recency bias in few-shot prompting and how do you prevent it?
Recency bias occurs when a model places disproportionate weight on the very last few-shot example in the prompt, tending to output a similar class or format to that final example. Because transformers process tokens sequentially and self-attention operates across the entire context window, the final tokens in the example sequence have high attention activation prior to generating the first output token. For example, in a sentiment classifier with 4 examples ordered, positive, neutral, negative, negative, the model is far more likely to predict negative for ambiguous inputs. A common mistake is grouping all examples of the same label together, placing all positive examples first and all negative examples last. As an interview tip, prevent recency bias by alternating example labels or randomly shuffling example order across batch runs.
Question 10. What is in-context learning and how does it enable few-shot prompting?
In-context learning is an emergent property of large language models where they perform new tasks at inference time solely by conditioning on context and examples, without updating parameter weights. Research indicates that multi-head attention layers in transformers act like implicit gradient descent algorithms during the forward pass. The model constructs a temporary subspace in its activations that encodes the task rules demonstrated by the few-shot examples. For example, showing an LLM 3 examples of a custom, made-up cipher language allows it to translate a fourth sentence accurately without any fine-tuning. A common mistake is confusing in-context learning with actual model training or fine-tuning, which permanently modifies network parameters. As an interview tip, use the term emergent inference time conditioning when explaining in-context learning in technical AI interviews.
Excellent. You've completed few-shot prompting, Part 1, Basic Fundamentals. In the next video, we'll dive deeper into using one-shot prompting to enforce strict JSON and XML outputs for API integrations. If you found this video helpful, please like, share, subscribe to SHR Trinity, and press the notification bell so you never miss our upcoming AI interview preparation videos. Thank you for watching. See you in the next video.